Now, we are going to start off by first analyzing and designing a 2D reinforced concrete frame in a building, because we need to learn how to crawl before we can walk and run. Now, as you can see on the screen, we have a 3+2 reinforced concrete irregular frame. So meaning in total, we have a 5 stories 2D frame. As we move from the first story to the fifth story, as you can see, there become an irregularity in height. And this is on the fifth story and on the fourth story, as you can see. So meaning the fourth and the fifth story is going to be more flexible compared to the stories below. Now, this was actually a research project of mine. Due to its irregularity in height, I performed a nonlinear pushover analysis on the frame to determine the location of plastic hinges on the frame. Now, in case you are wondering what this means, you need to know that there are two types of analysis we perform on a building. The first one is linear analysis, while the second is nonlinear analysis. For the linear analysis, this is when there exists a linear relationship between the force and deformation of a structure, in the sense that if we apply a load on the structure will deform, but if we remove the applied load, the deformation will return back to its initial position. While for the nonlinear analysis, this is when there exists a nonlinear relationship between the force and the displacement, in the sense that if we apply a load on the building or the structures, the building will deform. If we keep applying the load and more deformation keep occurring, instead of going back to its initial state, the building loses its ability to withstand the applied load. And the more the deformations that keep occurring, the building is finally going to lose all its ability to withstand the applied load. Then this is going to result to collapse. So let me show you this using the stress strain curve, so you are going to understand this better. So as you can see on the stress strain curve, if you look at the stress strain curve, we see that as we apply a load on the building is going to deform, and if we remove the load, the building is going to return back, that is, the deformation is going to return back to its initial state. That is why we have this slope. This is the slope. As you can see, we have a constant slope. So as you can see, if we apply a load on the structure, it is going to deform, it is going to deform, it is going to deform. Then it will get to a point, if we remove the load, it is going to return back to its initial state. So when it gets to its yield strength, this is where the slope is not going to be constant anymore. Then after the yield point, if we keep applying more load, the building is also going to lose more strength. It is going to lose its ability to withstand the load. So if we keep applying the load, this is how the deformation is going to look like. Then if we keep applying the load, then it will get to a point where it is called the ultimate strength. So this is the ultimate capacity of the building. Then at this point, we begin to see necking. As you can see, we begin to see necking, so that even if we remove the load, there is still going to be deformation on the structure, because right now the building doesn't have any strength. It doesn't have any strength to resist the load anymore. So even if we remove the load on the structure, there is still going to be more and more deformation. So from this point, this is the ultimate strength. So this is the ultimate capacity of the building. Then from this point to this point, if we keep applying the load, there's going to be more and more deformation then till it gets to the fracture point. So when you get to this point, the building is going to finally collapse. So from this point to the yield point, this is the linear analysis. Then from this point, the yield point to the fracture point, this is the non-linear analysis. Because as you can see, from this yield point to the fracture point, there is not a linear relationship between the stress and the strain. But for this point to this point, as you can see, there exists a linear relationship between the stress and the strain. Now, structural designers, they tend to design the structures for linear analysis. They design the structures from this point to the yield point. Now, why do they do this? They do this because they know that if they design the structure from this point to the yield point, although this is not the final capacity of the building, they know that the building still have some strength left to resist the applied load. So if they design the building from this point to this point, this is going to result to a good design, and it is going to result to an optimal design, because this is going to actually reduce the reinforcement, because now they don't need to worry about the non-linear part, because we know that this is not the final capacity of the building. We know that the building can still resist load if we design it for the linear part, but if we design it for the non-linear part, this of course obviously is going to result to more reinforcement. And like you all know, we always try to make our building very economical. We don't want to waste money, so we try to make the design very economical. So they tend to design it for the linear part. Now, for almost all code, all building codes, there is a limit as to when you can use the linear analysis and when you can use the non-linear analysis. So for some code, let's say if your building is of, let's say, 50-meter high or maybe 60-meter high, if it is more than 50 or 60-meter high, then this is when you need to consider a non-linear analysis, because for the non-linear analysis, we know that this is when the building is experiencing more and more deformation. So when this building is experiencing more and more deformation, then this will result to other effects like P delta effect. It will result to torsion. It will result to other non-linear deformation. So because of this, most building codes, they have a limit as to when you need to use the non-linear analysis and when you need to use the linear analysis. So it depends on the codes, which I'm going to show you guys later, when we can start using the non-linear analysis and when we need to stop using the linear analysis. So these are the properties. So the compressive strength of the concrete FC prime is 4 KSI, which is 4 K per square inch. So this is the compressive strength of the concrete we are going to use. Then the grade of rebar, the steel rebar, is 60 KSI. Then the dead load, which is the dead load of the beams and the columns, is 1 kip per foot, and this is distributed uniformly. As you can see, 1 kip per foot. The life load is 2 kip per foot, and this is also distributed uniformly. Then the unit weight of the concrete is 150 pcf, which is 150 pounds per cubic foot. Now this is the unit weight of reinforced concrete, because we know that the unit weight of reinforced concrete is a little bit higher than the unit weight of concrete itself, because we know that when we carry concrete, we usually have reinforcement steel, and also we also need to account for the unit weight of the reinforcement steel. So because we account for the unit weight of reinforcement steel, we tend to bump this up. So that is why we have 150 pounds per cubic foot. Now, the first step we need to take is, obviously, we need to create a new model. So this is the first step we need to take. So to create a new model, you go to the file menu, you click the file menu, then you click on new model. Now we have this window, as you can see on the screen. We have 3 settings. The first one is use save user default settings. So what this basically means is, let's say for example, you've created multiple projects, and the unit you use creating those projects, let's say you use the metric unit. Now if you want to use that same unit, all you need to do is you just need to save that unit on the project, and whenever you click on the use save user default settings and you click on OK, Etabs is automatically going to use that same unit So if, for example, you use American unit, Etabs is automatically going to use the American unit. If you use the metric unit, Etabs is automatically going to give you the metric unit. Then the second settings we have is use setting from a model file. So let's say, for example, you've created a model file from other software and you already inputted units in that software. So if you want to import those units in SAP 2000, let's say you want to use that same unit, let's say you've created multiple drawings, you've created multiple designs, and you use a particular unit for those drawings and those designs, and you want to use that same unit, you can click on use setting from a model file. Then if you click on OK, so Etabs is going to say where do you want to copy those units from. So you just need to click on where you want to copy the unit from and you click on open. So Etabs will automatically use that same unit. So I'll click on cancel. Hope you understand that. Then let's go back to the file menu. So let's go back to the file menu. New model. Now the last setting is use built-in settings. So this is basically the default settings of Etabs. As you can see, the display unit, the default is US customary unit because this is an American software. So the display unit is going to be in American unit. So if you want to change the default unit, if you want to change it to, let's say, the metric unit, all you need to do, you need to click on this drop down menu. Then you can change it to the metric SI unit, or you can also change this to the metric MKS. So I'm going to be using the display unit as US customary. So I'll click on this. Then we have still session database, and the default code Etabs is using is the American code, and this is AISC 14. So this basically stands for American Institute of Steel and Construction. Then for the steel design code, so this is when you want to design a steel building, then the default code is American Institute of Steel Construction, as you can see. So let's say if you want to change the code, if you live in India, you can change this code to Indian code. If you live in the UK, you can change it to the British code. If you live in Europe, you can change it to Euro code by just clicking on this drop down menu. As you can see, we have Euro code, we have the Spanish code, we have Italian code, we have the BS code, which is the British code, we have the Australia code AS, we have the Indian code IS. So I'm going to leave it on the default code, and I will cover other code later on in future videos. Then the concrete design code, so this is basically for concrete building. So if you want to design a concrete building, you just need to input the code you want to use. As you can see, the default code is American Concrete Institute ACI 318-14. So you can also change the code if you want to use other codes. If you want to use the BS code, you can change it to BS. If you want to use the Indian code, you can change it to Indian. So it depends on your choice and depend on the country you live in. So like I said earlier, we are going to stick with the US unit and we're going to stick with the US code. Later on in future videos, we are going to use other units and other codes. So we click on OK. So now we have this window. So now this is where we're going to configure the frame plans and the frame dimension. So the first one we have here is the grid dimension. So basically what this means is we can add the number of grid in the S direction. So all you need to do, you just need to input the number of grid you have in the S direction. Then the number of grid in the Y direction, you also need to input the number of grid in the Y direction. Then the spacing of grid in the S direction, that is the spacing from one grid to another grid in the S direction, and also the spacing from one grid to another grid in the Y direction. As you can see, these are in feet because we use the default unit as US customary unit. And this is used when you have symmetry in plan and symmetry in height. So let's say, for example, if your building has symmetry in height, let's say the building height from the ground story to the top story, if the heights are similar, and also if the plan is symmetry, that is the S direction is symmetry, the Y direction is also symmetry. That is, if you have the same distance in the S direction and also the same distance in the Y direction, then you can use the uniform grid spacing. All you need to do, you just need to input the number of grid you have in the X direction, in the Y direction, and you just need to input the spacings from one grid to another grid. And you can also change the grid label by clicking on this. So you can name it depending on how you want to call it. You click on OK. And if you have different spacing, if you have different heights, if the plan is not symmetry, or let's say if the dimensions are not symmetry, then you can click on custom grid spacing. So this is where you can edit the grid data. So click on edit grid data. So now as you can see, we have the X grid data and we have the Y grid data. So we can customize this depending on the dimensions we want. So if you take a look at our frame, as you can see here, this is the X direction. As you can see, this is the X direction. Then this is the Z direction. We don't have Y direction because this is a 2D frame. So we only have the X direction and the Y direction. As you can see, the dimensions are symmetry in the X direction. The distance from one grid to another grid is 22 feet, as you can see. Then in the Z direction, the dimensions are also symmetry. So we're just going to input this data. So meaning in the X direction, we are going to have 3 grid. As you can see, we have 1, 2, and 3 grid. While in the Z direction, we are going to have 1, 2, 3, 4, 5, 6 grids. So we have 2 options to display the grid data. The first one is the display grid data as ordinate, while the second is the display grid data as spacing. Now what the display grid data as ordinate means is, so let's say as we move from one grid to another grid, the distance is going to add up. So let's say if we move from grid A to grid B, the distance is 22 feet. Now from grid A to grid C, the distance is going to be 22 feet plus 22 feet, which is going to give us 44 feet. So as we move from one grid to another grid, the distances are going to add up. So this is what we know as the add grid data as ordinate. While if we click display grid data as spacing, meaning the distances are not going to add up. If we move from one grid to another grid, we just need to take the spacing from the previous grid to the next grid we are looking at. So this is the difference between the display grid data as ordinate and display grid data as spacing. So it depends on your choice. You can use any one you want to use. So I'm going to display the grid data as spacing. So as you can see, in the X direction, we have 22 feet and we also have 22 feet. So meaning the first spacing is going to be 22 feet. Then the second spacing is also going to be 22 feet. Then since we don't have any additional grid, then the last grid is going to be 0. So make sure you always end it with 0 when you choose the display grid data as spacing. So because we don't have any other grid option, then we can just delete this. You click on this and you click delete. So for the Y grid data, the Y grid data is going to be equals to 0 because we don't have Y coordinates. So we can simply just delete this. We can delete everything because we don't need it. Then we click on OK. So we are done with the S grid coordinates. So let's take a look at the Z coordinate, which is the story dimensions. So if you take a look at this, the story dimensions, you can input the number of stories you have. You can input the typical story height, and you can also input the bottom story height. So how many stories do we have? So as you can see, we have 5 stories. So we have 5 stories, so we're going to input 5 stories. Then typical story height. What is a typical story height? A typical story height, as you can see, is 10 feet. So I'm going to input this 10 feet. Then the bottom story height. So basically the bottom story height is basically the same with the typical story height. Or usually the bottom story height is usually higher than the typical story height. But in this case, we have same heights. We have similar height in this case. So we're just going to put 10 feet. So we are done. And also if you want to customize the story data, you can click on this and you can edit the story data. So because the story dimensions are similar, we are going to use the simple story data. So this is what we have. Now if you take a look at this, we have add structural objects. So we have different options. We have blank, green only, steel deck. You can also use stagger truss, flat slab, flat slab with perimeter beams, waffle slab, two-way or rib slab. So if you want to design a stick deck, you can click on this and you can modify the section properties. And if you want to design a staggered truss, you can click on this. If you want to design a flat slab, you can click on this. If you want to design a flat slab with perimeter beams, you can click on this. If you want to design a waffle slab, you can click on this. If you want to design a two-way or rib slab, you can also click on this, which we are going to discuss in future videos. So we are just going to stick with the grid only because we already inputted the grid. And after that, you click on OK. So this is how the view is going to look like, as you can see. So we have the plan view, and the total height of the frame is 50 feet. As you can see, Z is equals to 50 feet, while this is the 3D view. So you can change the view depending on how you want to look at it. So let's say we want to look at the 2D view because this is a 2D frame. So all you need to do is you need to go to the elevation. You click on set elevation view. So click on this. Then as you can see, the grid, it is showing in the alphabetical grid A. So in order to get the 2D view, we need to look at it using the numerical grid 1. So if we set it on the numerical grid 1, it is going to allow us to view the frame in 2D. So if we click on 1 and click on apply and click on OK, as you can see, we now have the 2D view. So this is the 2D view of the frame. So as you can see, this is the S direction, while this is the Z direction. Then this is the 3D view. We have the S direction, Z direction, and we have the Y direction. Now the next step we are going to take is we are now going to define the material properties. To define the material properties, you need to go to the define menu. You click on define. You click on material properties. So now as you can see, we already have some material properties that were defined, but we need to define a new material property. So to define a new material property, all you need to do is you need to click on add new material. So if you click on add copy of material, this is going to copy the previous material which you already defined. It's going to copy the exact same property. And if you click on modify show material, if you have already defined a material, you can modify and edit that material by clicking on modify show material. But because we want to define a new material, we are going to click on add new material. So you click on add new material. So as you can see, it is asking you to input the region where the material is produced. So like I said, we are going to be using United States because we are using the American code. Then the material type, we have different material type. We have steel, concrete, aluminum, cold foam, rebar, tendon, masonry, and other materials. So because this is a reinforced concrete 2D frame, we are going to click on concrete. Then the standard units, it is a customary units. Then now the grade of the concrete, because this is the concrete property. So like I said, we are using 4 KSI concrete, and 4 KSI concrete, this is equivalent to 4,000 PSI concrete. So as you can see, we have different grade of concrete. So we have 6,000 PSI, and this is lightweight concrete. So if you want to use a lightweight concrete, so depending on the application, you can click on this. So depending on the application, you can click on the grade of concrete you want. And 4,000 PSI, basically this is normal weight concrete. So we tend to use this. And if you want to use high strength concrete, then of course the grade is going to increase to 5,000 PSI or 6,000 PSI. But we are using normal weight concrete, and this is 4 KSI, which is 4,000 PSI. So you click on this, then you click on OK. So now we can name the material. So let me name this as 4 KSI concrete. So this is 4 KSI concrete. So the material type is concrete, like I said earlier, concrete. The directional symmetric type, so just leave it as isotropic. You don't need to change that. Then material note, so if you want to write a note concerning the material, if you want to describe the material, you can just click on modify show note, but there is no need for that. And the material weight and mass, so like I said earlier, the unit weight of reinforced concrete is 150 pounds per cubic foot, as you can see here. Then this is mass per unit volume, so you don't need to change these properties. as long as you've already inputted the grade of concrete, which is 4000 psi or 4 ksi, it is going to automatically fill up these data. So the modulus of elasticity, as you can see here, is 3604996.5 pounds per square inch. Then the Poisson ratio is 0.2, so you don't need to change these values. Then the coefficient of thermal expansion, this is it. The shear modulus, this is it. So this is what we have. So you don't need to change anything, you just need to click on OK. So now, as you can see, we now have 4 ksi concrete. Then you click on OK. So now we have defined the material properties. So before we move further, let's first of all save our model. So make sure you always save your model so that you don't lose your file when your computer crash. So to save your model, you click on File, then you click on Save As. So I'm going to save this as Etab tutorial. So I'll save this on Documents, then I'll click on OK. So now our model is saved, as you can see, Etabs tutorial. So this is where I'm going to stop. I don't want this video to be too long, so we are going to continue in lesson 3.